Okay, a couple of new topics today. We're going to be talking about the discriminant and modeling with quadratics. These are two topics we don't really go into detail in GCSEs. Hello Salah and Disha, welcome. So where are we? I think I'm on the wrong page. Okay, so I was having a quick look through before, of course, before we get into this. Okay, that's what we covered already, quadratic graphs. And we are on to the discriminant. The discriminant is something that you will have used already. It's part of the quadratic formula. However, it's not something we really talk about in detail in GCSEs. Hello, Kabalan. So today we're going to be talking about the discriminant and why it's useful. Okay, alrighty. So the discriminant. Let's read about the discriminant. If you square any real number, having some issues here. There we go. Oops. Apologies for this. Okay, there we go. Okay, let's talk about the discriminant. The discriminant, if you square any real number, the result is greater than or equal to 0. This means that if y is negative, the square root of y cannot be a real number. Look at the quadratic formula. The quadratic formula says x equals negative b plus or minus the square root of b squared take 4ac over 2a. And let's have a look at this term in particular, the square root of b squared take 4ac. If the value under the square root sign is negative, x cannot be a real number and there are no real solutions. If the value under the square root is equal to 0, both solutions will be the same. Okay, so for the quadratic function, f of x equals ax squared plus bx plus c. In the previous sections, we were talking about functions. The expression b squared take 4ac, that part of the quadratic formula under the square root, is called the discriminant. The value of the discriminant shows how many roots f of x has. Remember, we talked about what roots were of the function f of x. These are essentially where the quadratic crosses the x-axis, where that f of x equals 0. Or if we write it as y equals, it's where y equals 0. So these were the roots. And it's really important to get a good understanding of what roots are because they come up a lot throughout the course. So make sure you're understanding what we mean when we say roots. And we also talked a bit about where that word comes from, like roots. They're like the origin of something. So you could think about these as the points where the function is 0, kind of where it's not really where it begins, but I think that's the where the word comes from. So the value of the discriminant shows how many roots f of x has. That's the usefulness of it. So if b squared take 4ac is greater than 0, then f of x has two distinct real roots, basically two solutions. You know, if you try to solve a quadratic, you can get two solutions. Distinct, meaning they're both different. Real, meaning they're real numbers. Now, this is something you don't really talk about in A levels. You'd have to go into further maths, but the reason we say real is because you can have complex solutions. They are where the discriminant is negative. So we do get complex solutions, but no real solutions. That's why they say real there. So again, b squared take 4ac greater than 0 has two distinct real roots. If b squared take 4ac equals 0, then f of x has one repeated root. And if b squared take 4ac is less than 0, then f of x has no real roots. It would have complex roots again, but that's something you don't have to worry about. Okay, so this first situation is a graph like this, where it crosses the x-axis twice. If it's less than 0, we also looked at examples like that. So here's an example where the discriminant is less than 0. The graph does not cut the x-axis, so there's no solutions. And we didn't actually look at a situation where b squared take 4ac equals 0, where the discriminant equals 0, but that would be where the quadratic just touches the x-axis. So the x-axis would be a tangent to that curve. And then it says one repeated root because you get two of the same solution. Basically, they could also say just one solution. Sometimes they also say, there's different ways of saying this, but basically one repeated root or one root just means one solution for x. Okay. So that is the discriminant, and this is why we care about it, to find out how many solutions a quadratic might have. So here we can see it tells us you can use the discriminant to check the shape of sketch graphs. Below are some graphs of y equals f of x, where f of x equals ax squared plus bx plus c. And this is saying a greater than 0. Remember what that means? That means a positive quadratic. So positive smiley face, so the curve is facing upwards like that, like a smiley face. So if the discriminant is greater than 0, we have two distinct real roots, so it crosses the x-axis twice. If it equals 0, we have one repeated root, so it just touches the x-axis there. And if it's less than 0, we have no real root, so it's above the x-axis. And similarly, if we have a less than 0, so a negative quadratic, so frowny face, it crosses the x-axis twice for the discriminant greater than 0. If it's equal to 0, it just touches the x-axis, and if the discriminant is less than 0, it's below the x-axis, so it doesn't cross it at all. Okay, so what sort of problems might you be expected to solve in terms of the discriminant? So here are a couple of examples. Find the values of k for which f of x equals x squared plus kx plus 9 has equal roots. This is in the style of exam style questions. I've seen questions in A2 exams just like this one, so this is a really important topic to get to know. So it says if it has equal roots, well, firstly, we recognize what the values of a, b, and c are. So a, in this case, is 1, b is k, and c is 9. And then we write down the discriminant equal to 0. We plug those things in, and then we can solve for k. The next example says find the range of values of k for which x squared plus 4x plus k equals 0 has two distinct real solutions. So this is another way of saying two solutions, two distinct real solutions. You can kind of ignore these two words here. As long as it says two solutions, you know that the discriminant has to be greater than 0. So again, you recognize what the values of a, b, and c are. And for two solutions, the discriminant is greater than 0. You plug those things in, and then you can solve for k. Notice with two solutions, we only have an inequality, so we're only going to get a range of values for k. So k is less than 4. All right. Okay, so let's do some examples. Firstly, it says calculate the value of the discriminant for each of these 5 functions. This is just trying to get you used to like the discriminant and what it is. So let's just do a couple of these. So we're on to exercise 2G now. 1, and I'll do, we're on to 1A, and I'll just do a couple of these. So if f of x equals x squared plus 8x plus 3, remember the discriminant is b squared take 4ac, and we're trying to find the value of the discriminant. This is basically substitution. the class of COVID. B is 8, so we've got 8 squared, take 4 multiplied by A is 1, C is 3. So you're basically substitution, plugging them in, and then solve this expression. So 8 squared is 64, 4 times 1 times 3 is 12, so 64 take 12, that's 52, I believe. So there's the value of the discriminant. Let's just do one more. So part 2, g of x equals 2x squared, take 3x plus 4. Remember the discriminant is b squared take 4ac. I always suggest to write the thing in so it helps you to remember it. This is equal to b squared, negative 3 squared, take 4 times 2 times 4. Negative 3 squared is 9, take 4 times 2 is, 4 times 4 is 16, times 2 is 32. So here we're actually going to get a negative discriminant. So the difference here is negative 23. And so then for that function, we'd say it would have no real solutions. Okay. So I always leave a few for you to do in case you want to do some practice on that. Okay, part B. Using your answers to part A, match the same 5 functions to these sketch graphs. Well, we've only got 2 here, so let's just do it for these 2. So A, we had a discriminant of 52. That means we'd get 2 real solutions, and it was a positive quadratic. So which graph do you think it would match to? If you're there in the chat, I've got, let's call them graph 1, 2, 3, 4, and 5. Which one do you think this function would match to? And there's only one option that it could match to. So is it graph 1, 2, 3, 4, or 5? What do you think? Orange with Dream says 2. And Orange with Dreams, I think is correct. So it's a positive quadratic, so it's up that way. And it has 2 solutions, so 2 would be the only one there. The second function, I've got negative 23 as the discriminant, and it is a positive quadratic again. So for the second function here, g of x, which graph do you think that would match to in part B? Graph 1, 2, 3, 4, or 5? VK says 5. Orange with Dream says 3. Oh, we get 2 different opinions here. Interesting. Maybe someone else can chime in and be the tiebreaker. So one more person, if there's one more person there, could you possibly give your answer? Umar comes in with 5. So Umar is the tiebreaker. I think Umar is correct, as well as VK. So it's a Orange with Dreams. Notice that the function is positive and the discriminant is negative. So the function is still this way, but it has no solutions, no real solutions. So it's going to be above the x-axis. Good stuff. All right, on to, okay, so we didn't really have to write anything down for part B. On to 2, and you notice here it says EP, so it's an exam style problem. and a problem solving style problem. And as I said, I've seen these types of questions in the exams. So yeah, good practice. So let's do 2. So it says find the values of k for which x squared plus 6x plus k equals 0. So let's write down that function has 2 real solutions. So the way we do this is, firstly, let's write down the values of a, b, and c. A is 1, b is 6, and c equals k. And then let's write down, well, what would the value of the discriminant be? If we have 2 real solutions, it would be, well, firstly, the discriminant is b squared take 4ac. It would be greater than 0. So now plugging these values in to this expression, substituting them in, b squared is 6, so that would be 36 take 4 times 1 times k greater than 0. So negative 4k. By the way, so when we get to this step, you can kind of treat it like an equation, and you want the k by itself on the left hand side. So we want to get rid of that 36. How do we get rid of that 36? Subtract it from the left hand side and then divide through by negative 4. Also, remember, when you divide by a negative, you need to flip the inequality around. So this is going to be k less than negative 36 divided by negative 4 is positive 9. So that will be, I believe, the values for k less than 9, for which this function has 2 real solutions. Okay. Three looks fairly similar. Given that the function s x squared plus 8x plus s has equal roots, find the values of the positive constant s. Okay, this is kind of different because we have 2 unknowns. So let's give 4 a go. And if you see a problem and you'd like to give it a go yourself, pause at any time, and you can, and then give it a go, and then you can kind of see if see if you're doing it correctly or not. So keep that in mind if you do want to give any of these a go yourself. So anyways, we have a function sx squared plus 8x plus s, and it says it has equal roots. So firstly, let's write down the values of a, b, and c in this quadratic. So a equals s, b equals 8, and c equals s as well. So you can see we're still going to have 1 unknown. So the discriminant, b squared take 4ac equal to, equal roots, this is equal to 0. So now plugging these in, b is 8, so 8 squared is 64, take 4 times s times s. And actually I could write that as s squared, couldn't I? So s times s is s squared. And then we are trying to solve this. So solve it as you would normally solve an equation. I might bring that negative 4s squared onto the right hand side. So then I would have 4s squared equal to 64 divided by 4. 64 divided by 4 is 16, and then s equals positive or negative, the square root of 16 is 4, so positive or negative 4. And so it's saying find the value of the positive constant s. So when it says positive constant s, we can say s must equal positive 4, because Well, it tells us that in the question. Alrighty. Five says find the range of values for k for which 3x squared take 4x plus k equals 0 has no real solutions. Use a similar approach to the other ones. When it has no real solutions, remember that discriminant is less than 0. So I might leave those ones that I haven't done for you to do if you'd like to do them. Now we're at a later stage. So 6 says the function g of x equals x squared plus 3px plus 14p take 3, where p is an integer, has 2 equal roots. So where p is an integer, the function has 2 equal roots. Find the value of p. For this value of p, solve the equation x squared plus 3px plus 14p take 3 equals 0. Okay, so slightly extra, a bit of an extra step added there, but I think just using the similar approach we've been using, that should be fine. I guess the difference there is c is now an expression 14p take 3, but you still just let that equals c, and I think everything would work out. 7 says h of x equals 2x squared plus k plus 4x plus k, where k is a real constant. Find the discriminant of h of x in terms of k, and hence or otherwise prove that h of x has 2 distinct real roots for all values of k. This looks very similar to one of the exam questions actually from the sample papers, I think. Or it looks very similar to a question I've answered before, at least. But anyways, let's go ahead and do this one because it does look quite different. And it has a tip here. If a question part says hence or otherwise, it is usually easier to use your answer to the previous question part. Okay, yeah, so when it has this language, hence or otherwise, use part A to help you out. All right, so question 7, we've got h of x equal to 2x squared plus k plus 4x plus k. Find the discriminant in terms of k. So, well, let's write down a, b, and c. A equals 2, b equals k plus 4, and c equals k. So the discriminant is b squared take 4ac. Plugging these in, this would be k plus 4 all squared take 4 times 2 times k. Simplifying, we could expand these double brackets out. So k squared plus 8k plus 16, and negative 4 times 2 is negative 8k. And actually you notice then that something's going to cancel here. This 8k over here, this positive 8k and this negative 8k will cancel. So this will equal k squared plus 16. All right. And then it says, hence or otherwise prove that h of x has 2 distinct real roots for all values of k. So remember, when there are 2 distinct real roots, this is greater than 0. So this would be greater than 0. Oh, so we need to so this is what we need to show, but I mean, we could state this because it tells us k is a real constant. K squared must be positive, so this must be positive. Possibly I did part of part B in part A, so possibly that simplifying was part of part B. Yes, so all values of k, positive and negative. So k could be negative or positive, but okay, so we can say here then that so this is part A. For part B, I would just say k squared plus 16 must, or okay, let's just say it is greater than 0 because k squared is greater than 0. Any integer squared is positive. So therefore, h of x, therefore the discriminant of h of x is positive therefore h of x has two solutions. I think that's good enough, I think, for that proof. So I'm just going to go ahead and check, as I usually do, that I'm getting these correct. Alrighty, and if you've had a go at any, you can check those as well. So we're on to 2g. -52, -23, k, what was I doing? 2, oh, k less than 9. So this is kind of like a study with me rather than a lesson, I guess. S equals 4, but you can always challenge yourself to do some of the questions as well. So A was k squared plus 16, and then B was k squared is always positive, so k squared plus 16 is greater than 0. Yeah, basically what I said here. Alrighty. So that's the discriminant. Not too bad there. It's a fairly, what would I say? It's a fairly simple idea, but a fairly powerful idea in that just by looking at that discriminant, you can tell a lot about a function, about a quadratic function. Oh, there's also a challenge here. So the challenge says, prove that if the values of A and C are given and non-zero, it is always possible to choose a value of B so that f of x equals ax squared plus bx plus c has distinct real roots. How often do I do these? Every weekday. So far, I've been able to keep to that pattern. And that's what I'm aiming for, to do one every weekday. And, well, hopefully more people join in. But if people find more value out of watching the video afterwards, then that's fine as well. But I'm hoping more people join in on the live stream and it can be more interactive. Yes, the whole AS course, that's my aim. Yes, so I'm kind of, if you want to give your opinion on what time you think would be best, I've been starting at 11 a.m. I was thinking of moving to 10 a.m. And today, obviously, I was a bit late, but what is there a time you'd prefer? Do you think, is there a time people would be more likely to prefer? Okay. So the challenge says 11 is good. Okay. Cool. If we are given values of a and c, is it always possible to have a value of b so that the function has two solutions? So let's see. Remember, to have two solutions, the discriminant needs to be greater than 0. Okay, so what are the two situations we need to consider here? Remember, we're given values of a and c, so we could have a multiplied by c equal to a positive number, or a multiplied by c equal to a negative number. And in this case, a and c would both have to be positive or negative. And in this case, one would be negative, one would be positive. And for me, it doesn't matter which one is which, but the result matters, positive or negative, because actually let's consider each separately. If we have a multiplied by c as a positive, if we look at this inequality, we would have b squared greater than 4ac, and then b is greater than the square root of 4ac. So that would give us a value of b, because 4ac is positive, right? That was that condition. Hey Philip, welcome to the Year 12 live streams. These are the weekday live streams to help you to revise if you want to. Trumpzilla says, well, thank you. Cheers. Appreciate it. Glad you get something out of them. Okay, so we considered the situation where a multiplied by c is positive. And by the way, I'm doing this challenge here. So now we need to consider if ac is negative. So in this case, we can still write b squared greater than 4ac, and this would be true regardless of what b is, because this would be positive, this would be negative. So this is a bit of a funny proof. I don't really know exactly how to state it correctly. But basically what we're saying is A and C can be anything, we still get a value of B that gives us two solutions. And that's what the question is asking. Interesting question. I think I'd have to kind of think about it a bit more to give like a really good explanation, I think. But hopefully that makes a little bit of sense. Anyways, part B. So actually, just to finish that off, we would say, so therefore it is always possible to find a value of B to give two solutions. All right. I might just put some music on. Okay, part B says, is it always possible to choose a value B so that f of x has equal roots? So this is when b squared take 4ac equals 0. That gives you one solution, or equal roots. Again, just pointing out, when it says equal roots, that's the same as saying one solution or one repeated solution. So in this case, we would have b squared equal to 4ac. And now let's consider both. So again, if a times c is positive, b equals the square root of 4ac, that would be fine. But if a times c is negative, so either one of these numbers is negative, b has no real solutions. Okay. So it's not always possible. So no, it is not always possible. Alrighty. So that was the discriminant. Not too bad, right? We're on to modeling with quadratics. This is another new topic that we don't really touch in GCSEs. Modeling is all about modeling real world situations, which is, one of the most powerful things about mathematics. You can, if you can model a certain situation, that allows you to predict what's going to happen. It can also allow you to recreate that situation. So for example, quadratics are used for modeling all sorts of projectiles that are governed by the forces of gravity mostly, and that generally follows the pattern of a quadratic. Other types of models we use are things like the trigonometric functions to model waves. Waves are all over the physical world. Think about sound waves, light waves, things like that. We generally use the trigonometric functions because they look like a wave. You've seen the graph of the sine wave. The good thing about the sine function or the sine wave is it's periodic, so it repeats, and there's lots of things in the real world that repeat themselves. And also, thanks to this guy called Fourier and others, it was discovered that most waves can be broken down and simplified into different sine waves. So sound waves, for example, are sound waves are made up of components of sine waves. And that's sort of how I believe like the computers that create the sound, like the sound engineers and things, that's how they sort of work. Although I'm not an expert there, so don't ask me for further details. So modeling is really useful, really powerful part of mathematics, and we're going to introduce ourselves to it here with quadratics. But just be aware that you can model many different things with mathematics. And I was actually speaking to an engineer the other day. He has a YouTube channel, Tayyab Majid, and of course engineers are constantly modeling things with mathematics, and he spoke a little bit about that, and that was really interesting. So check that chat out. We actually posted it on YouTube if you want to see that discussion we had on his channel. Yes, Moonlight Sonata. Nice and relaxing. So modeling with quadratics. A mathematical model is a mathematical description of a real-life situation. Mathematical models use the language and tools of mathematics to represent and explore real-life patterns and relationships, and to predict what is going to happen next. Models can be simple or complicated, and the results can be approximate or exact. Sometimes a model is only valid under certain circumstances or for a limited range of inputs. You will learn more about how models involve simplifications and assumptions in statistics and mechanics. So you may have already seen some modeling in physics, for example. Quadratic functions can be used to model and explore a range of practical contexts, including projectile motion. Okay. So in this section, we're going to look at real-world situations that are modeled by a quadratic function. Here they give us an example. A spear is thrown over level ground from the top of a tower. The height in meters of the spear above the ground after t seconds is modeled by the function h of t equals 12.25 plus 14.7t take 4.9t squared, where t is greater than or equal to 0. Part A says interpret the meaning of the constant 12.25, and also these questions are all about interpreting the context. So you need to consider what the question is actually talking about. So if a spear is thrown from the top of a tower and t is the amount of time taken, the amount of time gone, or however you say that, then if t is 0, so at 0 seconds, the spear will be at a height of 12.25 meters. So in the meaning of in the context of the question, the 12.25 will be the height of the tower. So here it says the tower is 12.25 meters tall, since this is the height at time 0. Okay, part B, after how many seconds does the spear hit the ground? Here you let the height equal 0, because that's the height above the ground. So you're solving a quadratic that is equal to 0. We've done plenty of that already. C says h of t in the form, write h of t in the form a take b bracket t take c or squared, where a, b and c are constants to be found. This is completing the square. We've done that already, so we should be confident with that. I guess here is a good place to point out. You can see how this kind of compounds as you go through this course. You really need to get the hang of things before you move on, because it sort of assumes you know how to do completing the square already to do these questions. Part D says use your answer to part C, find the maximum height of the sphere above the ground and the time at which the maximum height is reached. Remember when we did completing the square, we also learned how to read the maximum straight from that expression. We said the maximum was the maximum was C, the coordinates of the maximum was C and A. So you can see here, they've done C, they've completed the square, and they've got C equal to 1.5 and A equal to 23.275. So the maximum height is A, and the time is the X coordinate, or 1.5. And here they tell us the turning point of the graph of this function would be at 1.5, 23.275. You may find it helpful to draw a sketch of the function when working through modeling questions. Also, I think it's worth pointing out, to solve a quadratic, we can factorize, use the quadratic formula, or completing the square. So we've learnt those three methods, and you've learnt them in GCSEs as well. Anything else? So given any non-exact numerical answers correct, give any answers correct to 3 significant figures unless specified otherwise. Okay, so 3 significant figures unless told otherwise. That's useful. Hello, Abdullah. Yes, I'm well, thank you. How are you? And it says always interpret your answers in the context of the model. T is the time after the spear was thrown, so it must be positive. Alrighty, let's get into some questions then. And these are all exam style questions. These are the types of questions you'll see in AS and A-level exams, just like these ones. So this is a really useful topic to get the hang of. But there's not that many questions in here, unfortunately. But anyways, I guess this topic will come up again in the second year, so that's fine. So we're on to 2H. Question 1. Alright, question 1 says the diagram shows a section of a suspension bridge carrying a road over water. It's funny how they describe that. A suspension bridge carrying a road. I guess that's what it does. I've never thought about it that way. A suspension bridge literally carries a road. Anyways, the height of the cables above water level in meters can be modeled by the function h of x equals 0.00012 x squared plus 200, where x is the displacement in meters from the center of the bridge. Okay, so I'm going to go ahead and write that function down. 0.00012 x squared plus 200. Oops. And it can even be sometimes useful to draw a little sketch to yourself. Which I'll go ahead and try to do. Why not? So here's my pillars. And here's my cable. Oh, terrible. Anyways, and these are my cables suspending the road, I guess. I was just saying Taib is an engineer, so he talks a bit about engineering and what he does in his work. Anyways, part A says interpret the meaning of the constant 200 in the model. So I have to read it again because I've forgotten. So H is the height of the cable above the water. So I guess we should draw the water in. And X is the distance from the center. Okay, so let's say this is the center here. That would be where X is 0. So when X is 0 in here, we would have H of X equal to 200. Another way of saying that is H of 0 equals 200. So that's at this point here. So the height of the cable above the water is 200. So in terms of the model, we could say that's the height of the road above the water. So we could say something like 200 meters is the height of the road above the water. Okay. Part B. Use the model to find the two values of X at which the height is 346 meters. Okay, so remember H is the height. So what we're going to do here is let this model equal 346. 346. So the height is 346, so let this equal 346, and that will give you a value for X. And then you have to solve this. So what could we do? We could subtract that from, well, actually, if we're solving for X, subtract 200 from the right-hand side. So 0.00012 X squared equals 346. Take 200, that's 146. Then divide it by 0.00012. We might need a calculator for that. Let's get our calculators out. And do 146 divided by 0.00012. I get this number. And I might go ahead and straight away square root that rather than bothering to write that down. I'll just square root that because X squared is going to equal that. So I need the square root to get a value for X. So I get 1103. And should I include the negative? That's the question. Yes, it says find the two values of X. So I need the positive and the negative values. So X is equal to positive and negative because we took a square root. Positive and negative 1103.026 and so on. And it doesn't say what to round off to. So should we round off to 3 significant figures? But then what would this be? This would be 1100. I'm not sure actually. Okay, so let's round this off to 3 significant figures. I have a feeling that might be wrong though, because you're losing some accuracy there. But anyways, so if we round to 3 significant figures, the 0 is the 3rd significant figure, so this would be positive and negative 1100. Because we just stay at 0 because 3 is less than 5. And then it says, given that the towers at each end are 346 meters tall, use your answer to part B to calculate the length of the bridge to the nearest meter. Okay, so the height of 346 was significant because that's the height of the towers. Let's go back to our sketch again. My terrible sketch. That's the height of these towers, 346. And we found the value of x to be to the nearest meter. It says the nearest meter in the question, 1103. So that was in both directions. Okay, so that was when the height is 346. So then for this question, it's saying given, it says calculate the length of the bridge. This was the bridge part. Well, once we've put the dimensions into the drawing, we have our answer. It's 2 lots of 1103, which is 2206. So for C, the nearest to the nearest meter, the length equals 2206 meters. And I should have used approximation symbols there because I rounded that off in part B. Okay. All right, not too bad for question 1. Good question. So, it was x equals 0 at the center. And we got 2 values for x for this function. We got a positive 1103, and we also got a negative 1103. Now, when we're talking about lengths, we don't put a negative in, but that's what that negative 1103 represents. It represents going to the left of that 0. So again, this was x equals 0 at the center. I guess that's an important point. It was in the center. So if we have a negative 1103, we're going to the left that way. Positive going that way. So if you want the entire length of the bridge, which is from each pillar, then you've got two lots of those. Yeah. Oh yeah. Also, because we took that square root, it was positive and negative. Okay. I'm wondering whether to do all of these or not. Usually they go from less difficult to more difficult. So should I do questions 3 or 4? That's the question. Question 3 or question 4? They will sell only 10,000 tickets. They also expect to sell 1,000 more tickets every time the price goes down by £1. So this is a linear equation. Sure. Question 4 looks a bit different. It doesn't really fit in with the other ones, so I might actually do question 2, leave question 3 if you'd like to do that one, and also question 4 I'd leave as well, as kind of a challenge because it does look a little bit different. Oops, not sure what's happening here. Okay, so I'm going to do question 2 then. Question 2 says a car manufacturer uses a model to predict the fuel consumption, Y miles per gallon. Gallon? Why is it talking about gallons and miles? Oh, well, so England is still in miles, isn't it? Although I thought that generally it was converting to the metric system. This is confusing. Why do they talk about gallons and miles? Anyways, Y miles per gallon for a specific model of car traveling at a speed of X miles per hour. Y equals negative 0.01x squared plus 0.975x plus 16, where x is greater than 0. So I'm going to write that down straight away. Plus 0.975x plus 16. And x is greater than 0 because it's a distance. Part A says use the model to find two speeds at which the car has a fuel consumption of 32.5 miles per gallon. Okay, so there's no interpretation question there. But if there was, what would it mean what would the 16 represent in that question? So when the distance is 0, the fuel consumption. Oh, a speed. So when it's traveling at 0 miles per hour, it's consuming 16 miles per gallon. Well, I guess it wouldn't be traveling anywhere, so that's fine. Or we could think about that 16 as like the base, or the average, possibly the average fuel consumption. Anyways, y is the fuel consumption, so we can let y equal 32.5, and then we can solve this. So we'll have negative 0.01x squared plus 0.975 x plus 16 equal to 32.5. And then we have a quadratic equation that we need to solve, and we've been doing this we're doing problems like this already, so we should be fairly confident with this. First thing I would do is bring that 32.5 over to the left hand side, subtract it, so then I have negative 0.01x squared plus 0.975, take 16.5 equal to 0. And now I wonder whether I could factorize that. I'm not going to try to factorize it, but I wonder if I could factorize it. Actually, okay, so let's just do a bit of experimentation here. Let's say we multiplied everything through by 1000. This would be 10x squared plus 975x take 1650 equals 0. Okay, that's too hard. Yeah, I'm not going to bother trying to think about that one. Okay, so we could use the quadratic formula completing the square. If we use completing the square here to solve it, that means we'd have to divide everything through by this coefficient, because remember, to complete the square you need a coefficient of x squared of 1. So rather, yes, I think the quadratic formula is going to be better here. So we can say x equals negative b plus or minus the square root of b squared take 4ac. Do you remember what that was called? That part under the square root, divided by 2a. And plugging things in, this is negative 0.975 plus or minus the square root of 0.975 all squared, take 4 times, going to run out of room, negative 0.01 times negative 16.5. Hopefully you can still see all that. Let me move it over a little bit. And this is divided by 2 times negative 0.01. Okay. Calculators are our best friends. I might simplify that first just so it's easier to put into a calculator. So this would be 0.975 squared take 4 times negative 0.01 multiplied by, I'm probably going to make a mistake with these, but anyways, 0.290625. Okay, so then I get 0.975, negative 0.975, take the square root of this, 0.290625. Well, didn't really need to write this down again. All I need to do is then use the answer key. So negative 0.975 plus the square root of the previous answer, and should use brackets there, I think, and then divide by 2. What would that even be? Negative 0.02. Negative 0.02. Okay, hopefully I entered everything correctly there. I get 21.795. And then let's do the negative. Now I'm actually going to have to enter the enter that in, because otherwise it'll use the answer from the previous one. 0.290625. Oops, I forgot to change that to a negative. my god. Oh yes. Wait. Okay, I'm fairly confident I've entered something incorrectly here. Although, they should both be positive, so 75.7. Alright, I'm going to just assume they're correct, and if they're wrong, then I'll pick that up when I check the answers later on. Part B says rewrite y in the form a take b multiplied by x take c all squared, where a, b, and c are constants. Alrighty, so we need to actually use completing the square here. As I was saying before, it's going to be kind of difficult because we have this coefficient of x squared. But it's still possible, of course, so I'll start off by writing this down again. And yeah, I think I'll just divide through by factorize out negative 0.01. Out of everything. So let's see, 0.975 divided by negative 0.01. That's negative 97.5. And then 16.5 divided by 0.01. Excuse me, 1650. And then I have this expression that I need to use completing the square on, so I can write x take half of this. Half of 97.5 is 48.75 all squared. Take that squared and then add on the 1650. So then I need to compute this. So this would be 48.75 squared. 1650 take 48.75 squared. It gives me negative 726 and so on. So, okay, let's just write another step down. So I figured, I calculated this final term. This was negative 726.5625, and then multiply that negative 0.01 out to all of the terms. So multiply this number by negative 0.01 and we get 7.26. And do we need to round this off to anything? Hey, welcome. Okay, let's write the whole thing out, although I'm wondering, should I round it off or not? But anyways, then we have left over, we have negative 0.01 multiplied by x take 48.75 all squared. So that should be my function or my quadratic in this form. A take b bracket x take c all squared, where a, b, and c are constants. So these are my constants. So a is equal to 7.26 and so on, that thing. B is equal to 0.01 and C is equal to 48.75. All right. Part B says, sorry, that was part B. Part C says, using your answer to part B, find the speed at which the car has the greatest fuel efficiency. So now we need to remember that when we write a quadratic in this form, that's the maximum, that gives you the maximum. This is like the, this gives you the turning point, I should say. So remember, the turning point of a quadratic, when it's written in this form, is C and A. So C is the x coordinate and A is the y coordinate. So what does that mean in the context of this question? Well, this would actually be a minimum, I guess. So this would be the minimum fuel consumption, and this would be the speed at which you achieve that minimum fuel consumption. So the speed at which it has greatest fuel efficiency is 48.75 miles per hour. Part D. Use the model to calculate the fuel consumption of a car traveling at 120 miles per hour. Comment on the validity of using this model for very high speeds. Okay. So the speed was x, so we need to plug 120 in for x to find y. So y is going to equal negative 0.01 times 120 squared. I have a feeling we're going to get some silly answer, but let's see. Okay, so all we need to really do for this one is plug it into a calculator. So negative 0.01 times 120 plus 0.975 times 120 plus 16. Yes, so it's going to be negative because the largest number in there is a negative, so negative 11. But wait, so what would this quadratic look like? It would look like, well, it's a negative quadratic, so there must be some maximum speed that it can model, and then it starts going down here. Okay, so obviously we cannot get negative 11 fuel consumption. But wait. So now I've confused myself. So if this is a negative quadratic, the turning point would be a maximum. So the y-axis was fuel consumption. In miles per gallon. And the x-axis was the speed. So was that was maximum fuel consumption. Okay, now I'm confused. Oh, so greatest fuel efficiency. Does that mean that the highest speed, sorry. So greatest fuel efficiency. What does that mean in this context? So I'm confused because this turning point we found was a maximum, and part C was saying use part B to find the greatest fuel efficiency. But this maximum would give us the highest fuel consumption. Oh, sorry, no, this is not the fuel consumption, this is miles per gallon. So this is giving us the greatest distance per mile. Yeah, okay, everything's fine now. So that would be the greatest efficiency at the maximum. And so then when we get a negative for the fuel, so the miles per gallon, we got a negative answer. So that means we're using negative 11 miles per gallon. So we're traveling negative 11 miles, which is of course impossible. So at some point this model obviously becomes unusable or invalid because it goes into the negatives. So we could say this model is invalid for high speeds. High speeds. Okay. All right, so now I'm going to go ahead and check questions 1 and 2. For this exercise, which was 2H. GH. The height of the bridge, the road, I said the road. Wait. Oh, bridge or road I think is fine. B was 1103. Okay, so in the examples they said round off to 3 significant figures, and then in the answer they've rounded off to 4 significant figures. Naughty textbook. Telling us to do one thing and then doing another in the answers. Not very nice. Anyway, the length was 2,206 to the nearest meter. Okay, so question 1 was correct. Question 2, I feel I did something wrong somewhere. Oh, hey, look at that. So I didn't enter them wrong. I just didn't round them off. So rounding them off, this was 21.8. And I should also give the units because there's a context to the question. So I always should give units in the answer. And this one was 75.7 miles per hour. For the two speeds at which the fuel consumption was 32.5 miles per gallon. Yeah. Ooh, this one's quite wrong. Actually, so B is right, C is right, A is wrong. What did I do here then? Now I'm a bit confused. I started around 11 AM. Today I started a bit later, but that's the plan, usually to start at 11 AM. So 1650 take 48.75 squared. Oh, did I what did I do? I factorized 0.01. Did I write that wrong? 16.5. Why did I write 16.5? That should be 16. And it's a positive. I just wrote that wrong for some silly reason. Oh dear, oh dear. No idea why I wrote that. It should be positive 16. That's where I went wrong. Usually every day. I love to do part of this. Yeah, every day. So every weekday, not on the weekends, but every weekday. Yeah, so join in tomorrow. I'd love to have your company. Okay. So yeah. Just made a mistake and I'm trying to fix it here. This is negative 1600. And then this would be negative 1600 take 48.75 squared, and then multiply that by negative 0.01. I get 39.76, rounded off 39.77, and there we go. So I just wrote the equation wrong at the start, and that gave me the wrong answer at the end. Unfortunately, a very common mistake to make is to write the question down wrong and then you get the answer wrong. It's unfortunate, but it happens quite a lot, even with me. The speed is 48.75, and so negative 11, a negative answer is impossible, so this model is not valid for very high speeds. There we go. Alrighty. So that is some examples of modeling with quadratics. We looked at a bridge, suspension bridge, and we talked about like interpreting the model and you know, finding the relationship between the height of the bridge and the length of the bridge. And then question 2, we looked at fuel consumption, a model for fuel consumption, which is actually very practical. This is likely how they would model something in the real world for fuel consumption. And we saw, we found speeds at which the fuel consumption was a certain amount. And we found the speed at which fuel consumption was the most efficient according to the model. So right there is the usefulness of these types of things. And we also looked at how models are never perfect. So mathematical models are really useful, but they're not always perfect. So for example, at high speeds, this model for fuel consumption is not valid any longer because they're getting negative miles per gallon. So that's clearly invalid. So there we go. I'll leave the others for you to have a go at. So there's question 3 and question 4, and then the challenge as well. Okay, we could give the challenge a go. So Wade, just before we get into the challenge, hello Wade, you say equation of a circle with a tangent. Depends what information you're given. Oops. I didn't want to do that. So if you just tell me a circle has a tangent, then yeah, it depends what information there is. I guess if you're looking for the equation, you don't have, what would you not have? So possibly you just have the equation of the tangent. And then I think you also need the center to find the equation of the circle. Is that right? You're given the center and the tangent? Tangent 8x plus 15y plus 17 equals 0. Okay, let's just do this one. So you're also given the center, right, of the circle? Okay, so let's assume the center is at 0, 0. Okay, so we have a tangent. Oh, center 1, 4. Okay, let's go with that. Center 1, 4. Haven't done these for a while, I'll be honest. So what's the thing you need to look for first? It's the gradient. Or is there an even easier way? So firstly, let's talk about the general equation of a circle. It is x, take the x coordinate of the center squared, plus y, take the y coordinate of the center squared, equals the radius squared. And now I'm trying to remember the method here. We could find the gradient. Is that the best way? Okay, I'm going to just start something, so I'm doing something. I'm not remembering exactly how to do these, but firstly you can find the gradient of the tangent. This would be what? This would be negative 8 on 15. Change in x, change in y. Exactly. And so the gradient of the radius, the gradient from the center to the tangent, gradient from center to tangent, is the reciprocal of that, so 15, sorry, the negative reciprocal, so 15 on 8. Then what? We need the equation of the circle. I'm forgetting how to do it. That's the equation of the circle, but we don't know the radius. So we have to find the radius. Oh. Hold up. Is there something to do with this? Point to line distance formula. Yes. Point to line distance formula, which I don't remember. How are we doing this again? It's I haven't used that for ages, actually. Point to line distance formula. I don't even know if I've used that in any of the A-level spec. I wonder why. That's strange. It seems like a very practical thing to know. So, okay, the distance formula is, as you say, x2 take x1 all squared plus y2 take y1 all squared. That's the distance formula between 2 points. Now, if the second point is represented by a line, it gets more complicated. And apparently the formula is a well, what's the A? I felt fairly confident that I'd be able to do this, but I'm not remembering how to do this at all, which is kind of worrying me. Okay. Actually, so this is the way I'm going to do it. I'm going to say this is the y-intercept of 17 on 15. This is the x-intercept of 17 on 8. And okay, so A is the coefficient of x. But which equation? The coefficient of x from the line Oh, yeah, of course, from the line. So, okay, so I'll write this down. bx1 plus c over the square root of a squared plus b squared. Huh. I don't know if I haven't used this for years, and I don't know why. by. But what I was going to say is you can also use the intercepts, and then this is a similar triangle. But that would involve finding that hypotenuse, so you could do it that way. So let's try to use this formula then. So the absolute value of a I guess this x1 and y1 refer to the points, so a times 1 plus b, sorry, not b, 15 times 4 plus 17 over the square root of 8 squared plus 15 squared. Eight plus 60 plus 17 over, actually let's just get a number for that. The square root of 64 plus 15 squared, I don't remember what that is. 17. What's this? 77. 85. Oh, that's going to go evenly. 5. Oh, nice. So the radius is 5. And then we have our equation. So cool. So all we actually needed there was the point to line distance formula. So just thinking. So anyways, the equation is now x take 1 all squared plus y take 4 all squared equals to 25. So how do we derive this? So this is this line with this point plugged into it. Oh, of course. So, oops, I rubbed that line out. So if we want the length of that line, we get the y coordinate and the x coordinate, and then find the hypotenuse, which is essentially what this is doing, kind of. Huh. Hey AJ Maths. how often am I doing these? Weekdays at 11 a.m. So that's, I'm playing some music, just some classical calm music. Weekdays at 11 a.m. And we were just talking about the equation of a circle from a tangent and a point. And for some reason I couldn't remember that point to line distance formula, but also I should have remembered that, I mean, what you're essentially doing is finding the X and Y coordinate here. And then kind of finding that hypotenuse to get the distance of the radius or the length of the radius, and then you've got your equation. Alrighty. You confused me there. Oh my god. Oh. 4 plus 1 is 5. Yeah, that's how you get the radius. Add the points. I'm a bit slow. We were doing the equation of a circle from the tangent and the center. And we used the point to line distance formula, which I haven't used for ages. Anyways, I'll think about that a bit later. Because I want to do this challenge here. And then we can talk about some other questions if you have other ones. So I just want to finish off with this challenge. To fit it in here into this session. Oh, and then I have to go. It says accident investigators are studying the stopping distance. Actually, maybe I'll leave this to the next one because it's quite involved. It might take a bit of time. So I'll leave that till the next one. I can fit it into at the start of the other one. So if you have any other questions right now, we can go through those. And we have some very helpful people at the moment that helped me with this question here. So that's good. Oh, that's big. I am working my way through the textbook, and someone asked me for the link earlier, so I'll just grab that. I do not have the PDF. As far as I know, it's I mean, you should be able to get a copy from your school, but I just got it off Amazon. So Philip, you're going to have to explain how the 4 plus 1 works with the radius. So anyway, let me get this link. I don't know why it's so long, but there you go. Oh, it's too long to even post. How do I share it? See if that works. So I've just posted the link to the textbook. Alrighty. Find the equation of the circle passing through -3, 1, and 1, 5. And the center lies on the line 3x take y equals 12. Oops. Oops. So it goes through the points -3, 1. Let's just say it's here. And 1, 5. And the center is on that line. Okay. Easy one. I don't even know how to figure this one out at this point. Okay. Oh, you could find that distance. Do I need to do that? This is some point X. Sorry, this is AB. Okay, so you can find. So it's like simultaneous equations with the distances. So R is equal to, if you use the distance formula, but we could use that point to a line formula again. So the distance from a point to a line, that was ax1 plus by1 plus c over the square root of a squared plus b squared. Let's use that again. So here's our line. Oh, perpendicular distance. Oh, okay. Oh, that makes a lot of sense. I was wondering why I couldn't think of where I'd seen it before. Yeah, so let's do the distance formula twice. So x, so a could be x2. Does it need to be the same point in each one? But that's 3 unknowns. Okay. Or we could do r squared. Let's do r squared. Is what? So a take -3, so a plus 3 all squared plus b take 1 all squared Does it matter which order I do these around? Oh, it has to be in the middle. No, it doesn't. Wait. So another way I could have drawn this diagram is like this. So I'm just wondering, does it matter if I do 1 take A or A take 1? So let the center be XO, YO, since C lies on the line, we have that equation. Solving for X and Y, we have X equal to something and Y equal to something. Okay. So A is equal to 12 plus B divided by 3. And then B is equal to 3A take 12. Sorry, just 3A take 12. And then plug them in. Oh, okay. Yeah, I see. Wow. The 2019 papers, yes, I have the 2019 papers for AS. That is way more complicated than I expected. So we need the two distance formulas. I think the order matters, right? So I still have this question of which order to put them around. So I'm just, well, the distance is still going to be the same, right? So it doesn't matter. As long as the 2 points are the same way. Yeah. Anyways, so actually that didn't matter. So I've got 1 take A and 5 take B all squared. And then I equate them. So A plus 3 squared plus B take 1 all squared equals 1 take A all squared plus 5 take B all squared. And yes, you're absolutely right. It doesn't matter what the order is. I'm not sure why I was getting caught up on that. And then we substitute which one? It doesn't matter, does it? So we can substitute B or A. If I substitute B in, I think that looks slightly easier. So we can substitute this value for B, which we got from this straight line, in here. And then it's all in terms of A, and then we need to solve. Whew. Run out of room. Jeepers. And then I need to solve this. Do I have to? Alright, so I've just got my head around it, I think. I didn't realize this would be as complicated as it is. So this 3a take 12 is from this straight line equation up here. This would be a fun problem to have thought about, actually. So because I said this is the center, if you put a and b into this equation, this would be 3a take b equal to 12, and then we can say b equals, do some algebra here, we can say b equals 3a take 12. You don't even need the equation of a line? Oh. I don't think I'm fast enough to do this one off the top of my head. I haven't done a problem like this for a while, so I have to sit down and think about it for a bit. But anyways, so hopefully that makes sense, where we get the b equal to 3a take 12 from that straight line equation. If I'm labeling the center AB. And then using the distance formulas for R, because we're given these 2 points, -3, 1 and 1, 5 on the circumference, we have the distance from the center of a plus b all squared plus b take 1 all squared, and then 1 take a all squared plus 5 take b all squared. That's how we would find the distance of R from the center. And then I equated these two things because R, they're both equal to R squared. So I can say this, let's use a highlighter, this equals this, because they're both equal to the radius squared. And now I end up with this whole thing, which I need to go ahead and try to solve. So I guess I'm just going to expand all of this out. There's probably some clever algebra you can do in here, but I am just going to do it the long way. This is 3a take 13 squared equal to a squared take 2a plus 1 plus -3a take 7 all squared. They would cancel. Oh, I hope everything doesn't just cancel here. (9a squared take 39 times 2, 78. Yeah, 78. Now I'm just simplifying everything in order to try to solve for A. (2142) A plus 49. Hello, Anonymous. Thanks for joining in. I'm trying to finish this off and then that will be the end. So you're just catching the end of it today. As long as I can solve this. I'm hoping everything doesn't just cancel out. Because then I'm kind of back to the beginning. And I made a mistake on the previous question as well. Oh. I'm gonna have to have a go at these questions later and then maybe make a video on them because they're good questions. Anyways, so 6, this is negative 72a plus 178, and then 40a plus 50. Then this is 112a equals 128. I probably made a mistake in here somewhere. This is probably meant to be 124, I think. So A probably equals 2. Okay. I'm going to leave it there. I'm going to think about these questions and think about how I would solve them. Mostly I was going off what you guys were saying for these questions because often my brain's not fast enough to kind of solve. If I see a question I'm not sure exactly how to solve it, yeah, it can take me a minute to think about, and you know, it's not the best for a live stream if I'm just sitting here thinking about how to solve something, especially if it sometimes takes me 5 or 10 minutes. So I don't just want to be sitting here for 5 or 10 minutes silently thinking about a question. So I'm going to think about these ones, come up with how I would solve them, make a video on them, and then hopefully post that later on. Alrighty. But thank you for the questions. I really love being sent like those interesting, challenging, difficult questions. So thank you very much for joining in. And sorry I couldn't answer them for you straight away. This is my email if you want to email me for those papers. Oh, that's a shame. Alrighty, thanks Philic. Alrighty, if you want to tune in tomorrow, I'll be live at 11 AM, around 11 AM. I'll see you then. Alright. Bye for now.